I'm just trying out something different actually, because yesterday when I recorded the video, or Sunday when I recorded the video, I couldn't have my face in it. Now you can see there's a little picture of me in the bottom, so hopefully gives you a bit more of a connection. This is Monday night, and I'm recording the lessons ready for tomorrow, because unfortunately Miss Slade won't be in tomorrow either. Hopefully we're going to try and get somebody, if you are listening, we are going to try and get somebody to be sat on the on the GoToMeeting login, so that if you are really struggling, you can log on and ask them some questions. But we're a bit short of TAs at the moment as well, teaching assistants, because Mandy's not well and Miss Cooper's not well, so we're struggling a little with people, but we'll keep going. Anyway, can I just first of all say thank you very much for your hard work yesterday. I was so impressed after teaching children all day and then coming on the computer and finding so much work that you had done, so thank you very much for that. I know this is a bit different to what you're used to, because of course normally you've got a live teacher there and you can ask them questions straight away, but I hope this sort of works. It's the best we can do for the time being, until we try and sort something out, or see what happens. But I quite like it, because actually if you're a bit stuck with something, or you're not sure about a problem, then you can always rewind the video and go back and listen to what I'm saying again, and hopefully that'll help you to understand a bit more. Also, if you're really struggling, because I'm going to do the same as I did yesterday, I'm going to do an answer video as well, so go over the answers. You can always have a little sneaky look, because I'll always explain in the answer video how you get the answer, so that may help too. Okay, so yesterday we looked at fractions, we looked at numbers greater than 1, fractions, and today we're carrying on really. It's much the same, so we're going to be looking at improper fractions to mixed number. And of course improper fractions are when you have the numerator which is bigger than the denominator. So that's what it is. So get ready, get yourself a piece of paper and a pencil, and we'll have a little go at these problems. So which fraction, having a little look at this, which fraction of the bar is shaded blue? Okay, so what you'd need to do first of all is you need to count how many sections there are, and then how many. So the how many there are will be of course your denominator, so that will go at the bottom. So how many are shaded in blue, that's your numerator, so that would go at the top. Alright, little bit of a clue there. Then we go with this one, what fraction of the bar is shaded green? So we've got 1, 2, 3, 4, 5, 6, 7, 8. I didn't realise you could do all these things. So there are 8 sections. Remember, out of it, remember that number there will be the denominator, so we'll go at the bottom. Then how many are shaded green? I think you might get that one. And then we go on to number 3. Again, we need to count all of the parts, and I know they're not together. So what we have to think of here, okay, is we can see, right, there are 1, 2, 3, 4, 5, 6, 7, 8 parts. Okay, remember that's the denominator, that goes at the bottom. So how many of those are shaded yellow? 1, 2, 3, 4, 5. And that would be the numerator, that would go at the top. So let's have a little look. Hopefully you've got some answers written down. Did you get 3/5 for that one? So three parts of 1, 2, 3, 4, 5 are shaded blue. This one's a little bit more interesting, because actually there's 1, 2, 3, 4, 5, 6, 7, 8 parts, and they are all shaded green. So it will be 8/8, or of course we often say that's a whole one, don't we? When the denominator is the same as the numerator, that's whole. And then down at the bottom, how many parts are yellow? We've got 1, 2, 3, 4, 5, 6, 7, 8. Hoping that's right. And we've got 1, 2, 3, 4, 5 eighths. Or will it be? Let's have a look. 5 parts? Indeed, 5 parts are yellow. So we were correct. Right, let's learn. This is the bit I enjoy. So I'm just going to have a quick sip of my tea. Haven't been in long. So let's learn. Let's have a little look. So we have a number line here, which starts at 0. 0 add a half would take us to half. Okay? So if we jump again what number are we going to get next? So if we jumped a half, and then we jump another half here, it's going to give us a whole one, or two halves. Two halves, we know, equals one whole. Yeah, think about a pizza. If you've got two halves of a pizza, put them together, it's one whole. So I think there's going to be a bit of a pattern here. So if we jump another half, how many halves will we have? And if you said three halves, you'd be absolutely right. And then if we jump, another half, how many halves will we have then? You can see a bit of a pattern. The numerator is going up, the denominator is staying the same. So if we've got 1, 2, 3, I should imagine, if we look at that pattern, there's going to be 4 halves. Yes, there is 4 halves. So jumping in halves, we've got 0, half, 2 halves, 3 halves, and 4 halves. So that shaded in there is 1 half. That shaded in there is 2 halves, which makes 1 whole, which is the same as that. Okay, so if that's 1 whole there, okay, what is 3 halves going to be? It's going to be 1 whole and 1 half. I feel that's that one there. 1 whole and 1 half. So now, if we've got all 4 parts shaded in, so it's 4 halves, what does that make? And if you said 2 holes, because look, we've got 2 holes there, you'd be absolutely right. 2 holes. So that's nice and clear. So again, just really quickly go through. So there we go. That's 2 halves shaded in. So that's the same as this here, which is what happens there. And that means one whole. Then we had another half, so 3 halves is the same as 3 halves, which is 3 here, which is the same as 1 1/2. And then if we have 4 halves, we know that that is 2 holes. Now we have a little look at this one. So we've got 3 halves. We can see that's split into 4. 1, 2, 3, 4. That's 3 halves. 1. There we go, 3 halves. So when we convert that, what would that be? Have a little think. How many wholes and how many halves? You can see up here this one here, because it's all coloured in, all shaded in, this would be a whole. Okay, and this isn't. This is just a fraction of the whole shape coloured in. So it's an improper fraction. An improper fraction is where the numerator is greater than the denominator, which is what I said at the very start. So that's when the top number here, the numerator, is bigger than the denominator. That's an improper fraction. Because actually, you can't have that, can you? If you've got a pizza that's cut in 2, that's equal. You would need an extra pizza to have a 3rd half. Okay, so we've got 1. Let me see that again. 1 moves at the top, that's 1 whole, and we've got 1 half. So 3 halves is the same as 1 whole, and again that's 1 whole, and there's 1 half coloured in there. And that is what you call a mixed number, because you've got a whole number and you've got a fraction. That's why it's mixed. It's a number with a whole and a fraction. Right, so how do these representations show mixed numbers and improper fractions? So, we look at this first one, have a little think, have a little think. That's what it says down there, it says think, think, think. Anybody got any ideas? There's some very interesting representations there. Okay, let's go through them. And again, if any time you need to pause to have a little look and have a think, please do. That's what's good about a video. You can do that. So, if we look at this top one. Okay, so we're looking at thirds, and we know we're looking at thirds because it is, I was pointing to the screen, and these parts are in threes. There's 1, 2, 3. So each whole number is divided up into thirds. Okay, so that's 1/3, that's 1/3, that's 2/3, and of course that would be 3/3. So that would be a whole. So what do you think would be there? So we've got 1/3, 2/3, that would be 3/3, or a whole. This one here, we could say is 1 and 1/3. That's because it's been changed, okay? If it is an improper fraction, it will be 4/3, which means this next one, 1 and 1/3, 1 and, there we go, 4/3. This next one here, oh, sorry, oh, didn't point to that one, but if it did show the answer to this one, do you know what it would be? Yeah, it would be 1 and 2/3, or 5/3. Yeah, and again, to try and work that out, you would say, right, how many 3's are in 5? It's 1 whole, and then how many are left over? 2. That would be 2/3, 1 and 2/3. Okay, sorry, it's like, okay, let's find out what this one is down here. So we've got these bars down here, which are divided up, and so what they're doing, they're moving that up to the top there to show 1, 2, 3, 4, 5, 6. So that's 6/6, or, of course we don't normally say 6/6, we would say 1 whole. And then down here we can see there are 1, 2, 3, 4 6 shaded. So I'd say that's 1 whole and 4/6, because we don't need that middle one, because none of them are shaded in. So it's 10/6. Again, if we were doing improper fractions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10/6 are coloured in, but we wouldn't say that. We would say 1 whole, which is showing at the top, and 4/6, which is showing there. So 4 of the 6 are coloured in. All right, and again, you could work out, if you're working at fractions, that one snuck up on me there, you could say, right, how many 6's are in 10? We know there's 1 6 in 10, so that's 1 whole one there, and there's 4 left over. From 6 to 10 there's 4, and that would be the 4/6. Now over here we've got, these look like, I don't know, they must be cups or containers with water or something in, but these cups or containers are showing like 2 whole ones, and this one here, it's only got half in, so it's 2 1/2. Or we're doing it in halves like that, you say 1, 2, 3, 4, 5 halves are full. Okay, 5 halves. 1, 2, 3, 4, 5. 5 halves. But we don't say 5 halves, we say, right, okay, there's 2 whole ones and there's 1 half. Right, convert this improper fraction to a mixed number. I really like this. I'll probably like it because it reminds me a little bit of pie, and I do like a pie. But actually it's really visual. So you can see at the top, these are divided up into 3's. Okay, they're divided into 3, each one. Alright, and you can see there are 2 whole ones. Okay, there are 2 whole ones here, which is just put a little thing around it to show 2 wholes, which leaves us with this one all on its own. So the answer could be 2 wholes and how many thirds? How many thirds are shaded in? If you said 1, you'd be correct. So it's 2 wholes and 1/3. So there we go, there's our 2. And then if we look at this one, we can see there's 1/3. And that's a really nice visual way of showing it. And you can do that. You can do that with fractions. You can draw them out. Thirds are quite easy to do. Halves are quite easy to do. Quarters are quite easy to do. When you start going above that, when you look at fifths and sixths, it's a bit harder to draw them on a circle like that, especially to get them as equal. They don't have to be equal, but they should be really. Okay, here's another one. Convert this improper fraction into a mixed number. So the first thing we're going to do is we're going to count all of these. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so there's 24. So that would go at the bottom. That's our denominator. That's the amount of pieces there are. That's the whole. Okay, so that's 24. So how many are there? Wait a minute. I think I may have made a mistake there. if he stopped me and said, "Oi, Mr. Andre, what are you saying?" Because we go 1, we go 6. Of course it is. So we look at 6. Okay, so how many 6 are shaded in? We only count one lot. Okay, we only count one lot here. Sorry. So we can see there's 6. 1, 2, 3, 4, 5, 6. So how many 6 are coloured in? We could count in 6s. So 6, 12, 18, 19, 20, 21, 22, 23. Or we could count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 sixths. Phew. That is a lot of sixths. So now we have to change that, because that is a very improper fraction with a great big numerator on top. We now have to do that. We now need to change that into a mixed number. So we can do that by doing our division and saying, right, how many 6s are in 23? Or we could look at this. This is really good up here, because this is really visual. So we can say, right, how many whole 6s are coloured in? So there's 1, 2, 3. So that's 3 whole ones. Okay, that is what I'm going to put. I'm going to put 3 whole ones. And then there are a few left over. So there's 1, 2, 3, 4, 5, 6 coloured in there. So there's 3 whole ones and 5 6. And I think that's the answer. There we go. We've got that little rectangle going around it to show us that there's 3 whole ones. So that's our 3. And then we've got this little one that goes around there to say, right, we need to just count the ones that are shaded. 1, 2, 3, 4, 5 of the 6. So it's 5 6. 3 and 5 6. Sorry, I got a bit confused at the start there. I'm not going to edit it out. Just we make mistakes, don't we? Right. So it's your turn. Have a little go at the questions 1 and 2 on the worksheet. They will be uploaded to your portfolios. I love looking at your portfolios, by the way. They're fantastic. I love the way you can write straight onto it. It blows my mind. Have a little look. Once you've had a go at those, come back to me and we'll carry on. You can press pause, or you can just turn me off. Right, I hope you've had a good go at that. So we're now going to move on, look at a few more. Okay, so now here we have another one. This time we don't have the visuals there. We don't have the visual that we had before, that nice drawing or the pies or anything else. So it says convert the improper fractions to mixed numbers, and this is why it's so important that we know our multiplication, that we know our division, because all of those skills that we've used in previous weeks we're going to be using now. So what you could do if you wanted to is you could draw 32 circles on a piece of paper, and then what you could do is you could then box those into 7s. So keep finding 7s and box them up until you've boxed as many as you can, and you may have some left over. Or if you're really confident with your number, you can say, right, how many 7s are there in 32? So in my times table, my 7 times table, I can count 7, 14, 21, 28. I can't go any higher than that, because if I do, I go above 32, I go to 35. So what I do is I say, right, 7, 14, 21, 28. That's 4. Okay, that's 4 whole numbers. Okay, so again, I would put 4, and then from 28 to 32, there's 28, 29, 30, 31, 32. That would be our 7ths. So there are 4 7ths. So I'm saying the answer is 4 and 4 7ths. There we go. So 32 divided by 7 equals 4, remainder 4. So that is the same as 4 7ths. So let's have a little go on this one. Okay, so a quarter, convert the improper fractions to mixed numbers. So 1 quarter means 1 divided by 4. Yeah? So that's basically what it means. So 32 means 32 divided by 7, which is that one there. And this is really nice and visual again. So there we go, they're showing, but there we go, like that. that there are 4 remainder 4, or 4 whole ones and 4 sevenths left. 32 divided by 7 equals 4 whole and 4 sevenths, or remainder 4. The remainders are what we then turn into the fractions, and the fractions will always be whatever the denominator is. Okay, oh, here we go. Now we're getting a little bit tricky. So it says convert these improper fractions to mixed numbers. And I say tricky only because it looks quite tricky because it's such a big number. So again we do our division and we say how many tens are in 107? Okay, and our tens aren't too difficult. So again we go 10, 20, 30, 40, 50, 60, 70, 80, 100. It's 10. Yeah? There are 10 tens in 107. Can't have any more because it's, it's that little 7's in there. So we know that the whole number is going to be 10. But what is the remainder going to be? We know it's 7. So then we then change that 7 into 7 tenths. So the answer should be 10 and 7 tenths. There we go. Now we have a little go at this one. How many 3's are in 22? And again, if you wanted to, because it's not such a big number, with 107 it'd be harder. And it would take you a long time to draw 107 circles. But you could draw 22 circles, and then you could box off all the 3's. And so, but I'm just going to count in 3. So 3, 6, 9, 12, 15, 18, 21. So that's 7. 3 7's are 21. So I know that the whole number is going to be 7. Alright? But we've got one left over, because 21 to 22 is one more. So it's 7 whole ones and 1/3. There we go. As long as you can do your division, you can do fractions like this. You can convert improper fractions to mixed numbers. It's just you need to know your division and your multiplication, because they're both same sorts of things. Just need to be confident of that. But like I say, if you find drawing 22 circles and then boxing off the 3's is more helpful for you, then do that. Whichever is best for you to work things out. I don't mind, and I quite like it actually when I see a child's piece of work or someone's piece of work and there's workings out everywhere. There's circles drawn and there's crossings out. I love to see it. I just love to see. As long as you get the correct answer at the end, or close to the correct answer, that's the thing, isn't it? It's up to you how you're doing. Right, this is looking a bit tricky, isn't it? So now we've got to find the value of this star and this rectangle. So 25 over star equals 8, and then there's a fraction. Whew. Jeez Louise, have a think about this one. Okay, so we know that whatever the number is underneath, that if we times it by 8, it is going to be under 25. It's going to be under 25. But it's also going to leave a fraction. So, what on earth could it be? It could be 9. No, it could be 9. Sorry. What on earth could it be? So I'm thinking, right, what number times 8 makes 24-ish? So I'm thinking possibly 3. Because 3 8's at 24, and that would leave 1/3. That's what I'm thinking. Let's have a look to see what the workings are, see what they say. So 25 divided by equals 8 remainder something. Okay, so I'm thinking 25 divided by 3 equals 8 remainder 1. Let's have a little look. So 12 divided by 3 equals 4. 12 divided by 4 equals 3. 25 divided by 8 equals 3 remainder 1. 25 over 3 equals 8 and 1/3. Look at that, spot on. I don't know why. Showed that at the bottom. That is quite tricky. That's not easy, that, finding the value of those. You have to really think. Right, so then have a go at the rest of the questions in the worksheet. I hope they're okay. Again, if you're not too sure about something, go back, watch it over again. Set my mistakes. Watch it over again. You can stop, you can pause, you can look at how somebody's worked it out on here. But also, if you're really stuck, go and have a little look at the recording of my answer video, because actually, as we go through the answers, you'll be able to work out how it's done, what I would explain as well. So that may help you too. Again, thank you very much yesterday. It's a little bit harder. It's ramped it up a little bit more today, but hopefully that will help you. If you do have any questions, you can send them to me. Unfortunately, because I'm teaching, I can't get to them as quickly as I'd like to. I do try and have a little look at lunchtime and things like that, but it's not always possible. So thank you very much again. I hope it was helpful, and remember, once you've done them, once you've had a go at the questions, please have a look at the answer video and you can mark your own. I noticed some people doing that yesterday, which was really good, so thank you very much for doing that. And it saves me a job too, especially if you mark them and put them straight onto the portfolio, because I can see these great big ticks, which is excellent. Ruby was very good at that. So thank you very much, and don't forget to come back for the answer video.